All right, I'm going to talk a little bit now about laser rangefinders for precision rifle shooting. I've got several things I want to go over. I'm going to try to keep this short, but there's a lot to talk about. Hopefully, some of this will be useful if you don't have a lot of experience with rangefinders or you're just getting into long-range rifle shooting. Okay, so the first thing I want to say is you need a laser rangefinder. All right, people out there will still tell you don't rely on electronics. You should be ranging your targets with your reticle, stuff like that. That's cool. You should know how to do that. I practice it. I understand how it works and how to do it, and I also understand the limitations of it. And you should too. Your ability to get a really accurate range using a reticle is really dependent on your ability to know exactly the size of the target you're trying to range. The more error you have in estimating target size, the more error you're going to have in your range. And it also relies on your ability to accurately read the size of the target in the reticle. And these reticles, they have their limitations. It depends on how finely the marks are separated in the reticle. It's pretty common now to have precision rifle reticles with 0.2 of a mil increments in the hash marks. Sometimes they'll even have 0.1 of a mil increments in places on the reticles for use for ranging like that. But your ability to read that, to look at the target, to lay the reticle across it, and to get a very precise read on how that target is milling in the reticle is going to determine how accurate you can be with getting a range. Right? And so you need to keep that in the context of what you're trying to achieve. If you're shooting a 12-inch target at 400 yards and you're milling it with your reticle, small errors in reading the reticle on the target will make, they won't make much difference, right? You might miss it by a 1/4 of a mil, and it'll be off, maybe have your range off by 12 yards. And that's not that big of a deal, right? That's only like maybe 1.5 inches difference in drop at that distance. But at 800 yards, small errors in reading the target on a small target on the reticle might make more like 30 to 50 yards difference in the range you're coming up with from milling it with the reticle versus its actual distance to the target. And then there's things like, if you're milling a target like this, if you're straight on with the target, then the dimensions of the target are going to be true, right? But as the target starts to turn away from you, right, it's not going to be 18 inches wide anymore. That's going to change depending on the angle of the target to where you are. And if you're, if you're elevated or you're shooting uphill, as the elevation changes, the height of the target's going to appear to change too, right? So you have to consider all those things when you're trying to mill with a reticle and understand how that affects your ability to make an accurate shot. If you're using a target like this and your accepted hit is anywhere in this 18 by 24 section of the target, then you've got a lot of room for error, right? But if you're trying to hit center hits on a target the size of this head box on this target, then your margin of error is much smaller, right? Especially at long range. So I would say, look into it, try to understand it, practice it, understand its limitations, and then use a laser rangefinder. Right now, the world's not ended. You can buy batteries. You can use electronics, so you might as well take advantage of it and use them because it's going to give you an accurate range of the target and let you make precise hits on the target. There's several types of rangefinders available. The most common handheld ones are going to be probably these monocular type rangefinders. It's going to be a 7 or 8 power magnification. Look through it with one eye, aim it at the target, and get a range of the target. Binocular rangefinders are getting pretty common. They're a little more expensive, but they do kind of take the place of having 2 separate pieces of equipment. So if you want a pair of binoculars for, observing targets, spotting, glassing fields, looking for targets, things like that, binoculars are going to be better. And if you have a laser rangefinder built into those binoculars, then you don't have to carry two pieces of equipment into the field. You just have the pair of binoculars. The only downside is they're bigger, right? And they're a little more difficult to do, like say mount on a tripod or something. You need a different mounting system sometimes for those. The other type is the gun-mounted rangefinders like this. These things have their limitations, right? It adds height to the profile of the gun. It creates more of an opportunity to snag. It makes it a little more difficult getting in and out of tight quarters to shoot from. And also, if you're shooting through a porthole or something, a small porthole might obstruct the laser. So, you can run into problems with these. Another thing with these is that it has to be aimed to be parallel with the center line of the scope, right? So this sits 2.5 inches above the center line of the scope. And when you mount it to the gun, you have to have your gun zeroed and then zero the laser so that it is parallel to the center line of the scope. So when you actually look at the target out at, say, 75, 100 yards, and you use the visible aiming laser that this has, the laser, is not supposed to be aimed to match the center of the reticle. It's supposed to be the same height above the reticle at the target as it is on the gun, right? And if you do everything right, and you set your windage and elevation with the laser up so that it's parallel with the center line of the scope, then you're going to be able to have the max effective range of the rangefinder. But there's some difficulty in that, right? Because if you don't take the time to fine tune this and really dial it in, then it's going to be converging or diverging from its aim point over greater distances, and you'll start to have some errors at long range, being able to range the target. So there's a little more work involved. Where this thing I think really shines is if you have like a tree style reticle that gives you elevation and windage holds below the main crosshair, then you can keep your turret on 0. You can point the crosshair at the target. This one's got a little remote here that you can use. Hit the button, range it. It gives you your drop data here, and then you just hold in the reticle, and shoot that target and then move on to the next. As soon as you dial the reticle, you lose your aiming reference. So if you're ranging and then dialing your dope, then every time you want to range a new target, you're going to have to dial back to 0. So that's some things to consider with one of these. They do have their place, and they are nice in certain ways, but they have limitations, and you just kind of have to understand that and work with it. If you change it between guns, then you're going to have to re-zero it. If you change the barrel on your gun and the zero of the rifle changes because you've switched to a different cartridge or something, if you got to re-zero the scope, you've got to re-zero the laser. So it's just something to keep in mind for that. I think the most useful kinds are going to be the binocular style and then the regular handheld rangefinders. Okay, there are a few things to keep in mind when you're picking out a rangefinder. You want to make sure you get a rangefinder that's rated to have a maximum ranging capability well beyond what you're actually planning to use your gun for. Okay, so if you're going to be shooting 1,000 yards, and that's about all you plan on ever doing with your gun, you're probably going to want a rangefinder that's rated out to like 1,600, 1,800, 2,000 yards, something like that, because the way these are usually rated is in optimum conditions with like a maximally reflective target, right? So like this Bushnell 1600, this is an older rangefinder that I started out with, and it's my backup now. It says it's rated to range at 1,600 yards, and I can get ranges like that or returns like that on, say, like a building on an overcast day. It'll range stuff that far, but as the conditions and the types of targets change, then the effective range of the rangefinder decreases. So smoke, fog, snow, rain, mirage, just about anything that will obstruct your ability to see the target will affect the ability of the rangefinder to get a range on it. And how much it affects it really just depends on the quality of the rangefinder and the quality of the algorithm, how they have the rangefinder programmed to be able to pick out a target. The other thing that can make a difference is direct sunlight, right? So even though obviously direct sunlight makes it easier to see the target, it can also wash out the laser. So the brighter and more direct the sunlight is on the target, the more that can reduce the effective range of the rangefinder. So those are a few things to keep in mind. Like a really good rangefinder will deal with smoke and fog and snow and things like that better. It'll range through rain. It'll deal with bright sunlight better. But to some extent, greater or lesser degree, all those things are going to affect the effective range of the rangefinder. One of the nice things about modern rangefinders is that a lot of them are coming with ballistics solvers built into them, right? So you can get the binocular style or the handheld style like this, and you can use an app on your phone and connect to the rangefinder and put in all your ballistic data just like you would with an app on your phone, like for a ballistic solver or a Kestrel or something like that. And the rangefinders will usually have some amount of environmental sensors in them, like temperature, humidity, barometric pressure, and you can even input wind information. So if that if it's got and they've got a built-in compass too, right? So you get your compass calibrated, input your wind direction and average speed into the rangefinder, and then as you range different targets, it'll keep track of where the wind was coming from, as far as what you told it, and it can give you an estimated wind hold when it gives you your drop data for the target. But it's still up to you to keep in mind, monitor changes in the wind direction, changes in wind speed, and account for that yourself. So you're still going to need to learn how to make wind calls on your own, but it can be helpful, right, to have that data in there under certain circumstances. Another thing to be aware of when you're using handheld rangefinders like this is that some of them have a gate feature where you can have a preset in the rangefinder, or you can adjust it to set the range at which you want it to disregard returns, right? So if you're in an area with some tall grass, or you're in a brushy area and there maybe are like some twigs, or like I said, small pieces of grass blown in the wind, something like that, they're interfering a little bit at a closer range, and you're getting returns like 20 yards or something like that, and you're trying to range like a 800-yard target. A lot of times they'll have a feature in them where you can turn on the gate function and it will disregard everything, say, closer than 40 yards. Or you may even be able to set it, like say you don't want it to return anything under 200 yards or whatever. Those are some things to be aware of. If you're having problems with returns in certain conditions, there's ways that you may be able to compensate for that in the rangefinder. Now, as far as use goes, there are a few tips I can give for use. Obviously at closer ranges, just holding the rangefinder up to your face may be enough to get a good range on it, on the target. As the distance increases, it's going to need to be more stable. So you may need to take up like a seated position and rest your elbows on your knees, and brace the rangefinder up against, your eye, like your eyebrow right above your eye, or use your offhand to touch your face or something. Anything you can do to increase that stability is going to increase the range, that you can get effective ranges with this. Using a tripod is handy. If you don't want to set up in a tripod mount, you can use a sandbag. If you do have a tripod in the field, you can do something like this, where you use your tripod and use some type of a sandbag, right? And set the sandbag down on the tripod, and then set your rangefinder on that. And now you have a much more stable position for your rangefinder to get your ranges. If you're not using a tripod in the field like that, what I'll do a lot of times when I'm behind the gun and I'm not using this kind of rangefinder is I might just take my rear bag and set it across the scope like that, and then set the rangefinder on top of it. I just kind of scoot up over top of the gun, set it up here, look through it, and now it's a lot more stable and I can get, good returns on my target with this. Another thing that you need to be able to do, to get the best results with your rangefinder is take the time to learn exactly where on the reticle the beam is hitting, okay? So when they build these things, like this one's got an LED reticle, which looks like a segmented circle. Some of them may have like a crosshair looking deal, whatever. There'll be different types of reticles in these depending on who makes it. And some of them you can change the reticle in. But the main thing is to take a little time when you first get the rangefinder and, pick a target 500 or 600 yards away, something like that, 400 yards away. And what's really good to use is like a sign, some type of a square sign, something where it doesn't have anything in the near backdrop to it, right? So if you range the center of the sign, maybe you get like 500 yards to it, right? And then if you range off the edge of it anywhere, you get 50, 60 yards further. So you can know for sure when you're off of it. And then take the time to range it with different parts of the reticle to see where exactly on the reticle you have to hold it, right, to get an accurate return. So start ranging higher and higher on it in the reticle until you're shooting over the top of the target. And then pick, one of the vertical sides of it and start ranging further and further to the right or the left with the reticle until you start missing the target. And that'll give you an idea of exactly where you need to hold, because as you get out to longer distances, it'll get harder and harder to get accurate ranges on the target without knowing exactly where the laser is hitting in the reticle. Like I said, get a rangefinder, learn how to use it, work it into your gear, and if you're worried about having a failure, carry a spare battery. If you can afford to, carry a spare rangefinder. Learn a little bit about ranging with a reticle so that you have a backup plan, and hopefully that helped. So thanks for watching. Hopefully that was good information. If you have any questions, leave them in the replies, and if I can answer them, I will. Thanks.